Hello everyone, welcome back to another episode. Today we're going to be doing maybe the last kinematics problem for a little bit. I'm excited to graduate onto some more interesting things, but first we have to conquer this problem, which actually gave me a little bit of trouble. So let's dive right into it. They want us to find the minimum angle that the ball must be kicked in order for it to pass through the goalpost for a point after, and the velocity required when this angle here is 45 degrees. So to get the problem started, if you've noticed, these units are in feet, and when we're doing kinematics, like when we're doing kinematics for part B, and when we're doing kinematics, it's important that we have these measurements in meters because our acceleration in the y direction is in terms of meters per second squared. And so I went ahead and wrote down the conversions for these feet to meters, and if you notice, the feet is going to cancel with the feet there and leave us with meters, and the feet's going to cancel with the feet there and leave us with meters, and this right here is going to give us 10.98 meters, and this one to the right is going to give us 3.05 meters. So this is also equal to 10.98 meters. That's equal to 3.05 meters. Okay, so I don't like those. Let's get rid of them and replace them with meters. Next, we're going to calculate theta minimum. And turns out this is pretty easy because you can imagine this making a right triangle with the goalpost here. And it'll look something like this. So here's the base of the ball. And we've got this vector here, which can represent your velocity or just the angle at which the ball is going to be kicked. And here's our x distance, which was 10.98 meters. And here's our y distance of 3.05 meters. We said this one was 10.98. And then this is going to be theta minimum. And if you noticed, the tangent of theta is equal to the opposite over adjacent, which is 3.05 over 10.98. And using the inverse tangent, we get theta is equal to the tan inverse of 3.05 divided by 10.98. And making sure that our calculator is in degrees, you should get a theta minimum of 15.52 degrees. That answers part A. Here we go. Part A, done. Theta minimum is found. Turns out it's 15.52, and all we needed to do was draw a triangle and use the inverse tangent. Okay, so for part B, this is going to be the tricky part where we're finding the required velocity to make it through the goalposts when theta is equal to 45 degrees. So I went ahead and redrew the picture down here. I said velocity is equal to what? What is the velocity required when we have an angle of 45 degrees to make it through the goalposts? And I also recorded our new measurements in meters instead of feet here and drew what the arc's going to look like. So let's dive right into it. Turns out we're going to want to start in the y direction. So we're going to start in the y direction for the kinematics. And we know that the ending height, this y final, this y term, we know that our ending height has to be this 3.05 meters because if it reaches exactly 3.05 meters, it will just barely make it through the goalposts. So we can call this 3.05 meters. We can call y initial 0 meters because we're at the ground. Vy naught, well, let's take a look at our velocity vector. So as you know, I like to draw the velocity vector. So here's our velocity vector. We called this v, and if this is vy naught, and the vy naught is pointing up, and the vx naught is pointing to the right, and this angle is 45 degrees, we know that vy naught is equal to v sine 45, and vx naught would equal v cosine 45. Okay. So boom. Vy naught is v sine 45. meters per second. Vy final, we don't necessarily know. That part tripped me up a little bit, but we don't necessarily know what Vy could be, right? Because we're not saying necessarily that it's at the arc, and if you notice by the way that I've drawn this parabola, we hit a spot where Vy does equal 0, but I'm not going to set Vy to equal 0 there because we want it right here. So we don't know what Vy is going to equal there, so I'm going to label that with a question mark. Acceleration due to gravity in the y direction is negative 9.81 meters per second squared. Time it takes to get there, we don't know. So let's do the long equation. Y minus y naught is equal to initial velocity in the y times time plus 1/2 ay t squared. All right, now time to plug in what we know. We know y final is going to be 3.05. We know the initial y at the ground is 0. Vy naught we said is v sine 45 degrees. Time we don't know. Acceleration due to gravity is negative 9.81 meters per second squared. So we get 3.05 is equal to v sine 45 times time minus 4.905 t squared. Okay. Great. Now it turns out that if we were to do the short equation, which is the Vy minus Vy naught is equal to Ayt, we know that Ay is negative 9.81. We don't know time. We know initial, we sort of know initial. We know in terms of V. It's V sine 45, but right, we don't know this. We don't know final Y. So we have let's count. We've got 1 unknown, 2 unknowns, 3 unknowns. So we've got 3 unknowns, 2 equations. We know that we can't solve this. So this is exactly how I know that we need to move on to the x-coordinate. Because when we move on to the x-coordinate, we can get an expression for a variable that we need to find, or a variable that we need to plug in for to solve for v, because we want to solve for v, because that's the velocity that is required for this football to be kicked at an angle of 45 degrees. And because I have 3 unknowns and only 2 equations to solve it, I know that I need to go into the x direction. So here I have the table set up for the x direction. We're going to say the x final, this x right here, this x final, is going to be this 10.98 meters, because at 10.98 meters, it's going to make it through the goalpost, and anything less than that, we're not going to make it. Anything more than that, and we'll have a velocity that is in fact more than the velocity required. Does that make sense? So if I set anything larger, then I'm going to get a velocity that's actually bigger than one that I need, if that makes sense. Anyways, the point is 10.98 is going to be our x final. So 10.98 meters, x initial is 0 meters, vx initial we said was v cosine 45 meters per second. Vx is equal to Vx initial because acceleration in the x direction is 0 meters per second squared. Time it takes to get there, we don't know. All right, let's do the long equation. X minus x naught is equal to Vx naught times time plus 1/2 ax t squared. We know acceleration in the x is 0, so that term is gone. We know that x naught is 0, x is 10.98. We know that Vx naught is V cosine 45 degrees. We don't know time, so we're left with 10.98 is equal to V cosine 45 times time. Now this is where we're going to want to solve for a variable that is going to help us with, we're going to need to solve for a variable here that's going to help us up here, because we've got too many unknowns and we can't solve for them. But at this point, we could either solve for v or solve for t. And that way, we can, whatever we get from that, we can plug in here and get our answer for v. It turns out the more direct route to get v, in other words, the quicker way to get v right here, to get v, is to solve for t. That way I have everything in terms of v, and everywhere that I see a t, I'm replacing with some v term. So I will solve for t. T is going to equal 10. 10.98 divided by V cosine 45 degrees. Boxing it in blue because we're going to be making a substitution. Now, like I said, we're going to take this equation here and we're going to bring it down all the way over here. And everywhere that we see a t, we're going to plug in that expression that we just made. So, boom. There we are. And it's going to look something like this. We're going to get 3.05 is equal to V sine 45 times 10.98 all over V cosine 45 minus 4.905 times 10.98 divided by V cosine 45. Don't forget to square it. All right. So doing a little bit of algebra, doing a little bit of calculator work, making sure to square the 10.98 and the cosine 45 and the V squared and distributing this in. Just doing a little bit of algebra and a little bit of calculator work. I'm going to simplify it to be this. 3.05 is equal to 10.98 times tangent of 45, right? Because sine over the cosine of the same angle is tangent of that angle. And if you notice, the v's are going to cancel. We've got a v here in the numerator and a v here in the denominator. Those are going to cancel. And we're going to get the minus 1182.7 divided by v squared. There we go. Now what I'm going to do is I'm going to solve for v, or at least do some algebra to get there. I'm going to take you the steps along the way. So I'm going to take this term, add it over to the other side, so eventually I can isolate v squared. I'm going to subtract this over. It's going to look like this. So we've got 1182.7 divided by v squared is equal to 10.98 tangent 45 degrees minus 3.05. This whole term, including the 3.05, is 7.93. And then solving for v, I'm going to multiply the v over here, divide over the 7.93 over here, take the square root of that, and I get v is equal to the square root of 1182.7 divided by 7.93, and that gives us a minimum velocity of 12.2 meters per second. And there it is. That is the speed that the ball must be kicked at 45 degrees in order to clear the goalpost. A little bit of a tricky one, I'm not going to lie to you. This one gave me a little bit of a hard time, but we solved it. I hope it makes sense. If you have any questions, feel free to leave a comment in the comment section below. I'll be sure to get back to you. If this video was at all helpful, give it a thumbs up. Happy New Year, everyone. It's January 1st, 2021. I hope you all have a great year, and good luck in your next semester, next quarter, next trimester, whatever you got going, or your next job interview, or whatever. If you found this channel, if you found this video, thanks for watching, and we'll see you next time.